So the first thing, before I show you that interesting relationship, there's another technique of integration called partial fractions that we might use to do the integral of dx over x squared minus 1. So this is not related to arctan, because that arctan is x squared plus 1. Mm-hmm. So here we have to write this as, because we don't know how to do this integral, but we could split this into pieces, a over x minus 1 plus b over x plus 1 dx, where a and b are constants. We can try to see if we can solve for what a and b are. And I think it turns out one of them is a half, one of them is minus a half. So I think this is 1 over x minus 1 minus 1 over x plus 1. That would always be positive as long as x was bigger than 1. So that's right, a half outside. See what happens when we combine these. You get a common denominator, which is going to be x squared minus 1. And you get x minus x, and then you get 1 minus minus 1. So you do get 1 over x squared minus 1. And so when you integrate this, you get 1/2 ln absolute value of x minus 1 minus 1/2 ln of absolute value of x plus 1, which we could just write as 1/2 ln of x minus 1 over x plus 1. Let's see. If I was able to do that last step.
Just going from this to that.
Going from 1/2 log of absolute value of x minus 1 minus 1/2 log of x plus 1 equals 1/2 log of x minus 1 over x.
Because logs work that way. They work kind of like exponents, where if you have a log minus another log in the same base, the same as the log of the quotients.
Okay, good. So it's strange. The integral of 1 over x squared plus 1 is arctan, and the integral of 1 over x squared minus 1 is this 1/2 log x minus 1 over x plus 1. So it's a little surprising that small of a difference could be result in going from arctan to log, but we saw previously that arctan and log somehow are connected. But here's a new way that they're connected, and this came from one of Patrick Connor's students.
Okay.
Okay.